Welcome to Unit 4, Integration Part 1, Antiderivatives, Riemann sums, FTC Basics, Calculus AB, Part 1. What is antidifferentiation? Antidifferentiation is the reverse process of differentiation. Integrating a derivative will give you the original function. This is the notation for integration. The integral of the derivative of the function equals the original function. Part 2. What is the reverse power rule? When is it used? The reverse power rule is used when taking the antiderivative of a term that is raised to a power. If you know the power rule, this one is fairly simple. To use the reverse power rule, add 1 to the exponent and then divide the term by the new exponent. Try this. Find the antiderivative of 10x. The answer is 5x squared. Part 3. What are the basic antiderivative rules for trig functions? The integral of sin x is negative cosine x plus c. The integral of cosine x is sin x plus c. The integral of secant x tangent x is secant x plus c. The integral of cosecant x cotangent x is negative cosecant x plus c. The integral of secant squared x is tangent x plus c. The integral of cosecant squared x is negative cotangent x plus c. Do not forget the plus c. This is the constant of integration and must be used when evaluating indefinite integrals. These rules may look similar to the basic trig derivative rules, and they are simply the trig derivative rules in reverse. Part 4. What is the antiderivative of e to the x? What is the antiderivative of 1 over x? The antiderivative of e to x is very simple. It's e to x plus c. E to the x is an interesting case because whether you derive it or antiderive it, it always stays the same. The antiderivative of 1 over x is the natural log absolute value of x plus c. Part 5. What is the antiderivative of a constant? The antiderivative of any constant is equal to the constant times the variable that the function is derived in respect to. Here are some examples. The integral of 5 is 5x plus c. The integral of 15 is 15x plus c. The integral of 1000 is 1000x plus c. Part 6. What is the general solution of a differential equation? A general solution to a differential equation is a function that includes all possible solutions to the equation. It is found by taking the antiderivative or integral of the derivative, and it typically includes an arbitrary constant c, since there are infinitely many functions with the same derivative. In other words, when solving an indefinite integral, one without specific bounds, you're finding a general solution that represents an entire family of functions. Here is an example. dy over dx equals x. Taking the integral of this, you get 1/2 times x squared plus c. This is the general solution. Part 7. If given an initial condition, how do you find the particular solution of a differential equation? Let's use the example. f prime of x equals x plus 5. The initial condition is when x equals 2, the original function equals 15. First, find the general solution through integration. Using the reverse power rule, the first term equals 1/2 x squared. Using the reverse constant rule, the second term is 5x. Now that we have the original function, we can use the initial condition to solve for the constant of integration. Substitute 2 for x. We get f of 2 equals 12 plus c. We know that f of 2 equals 15, so subtract both sides by 12, and we get c equals 3. Plug in 3 to the original function, and this is the particular solution. Part 8. What are left and right Riemann sums? How are their approximations affected by a function increasing or decreasing? Left and right Riemann sums are methods for approximating the area under the curve using rectangles. In a left Riemann sum, the height of each rectangle is determined by the function's value at the left endpoint of its base. Conversely, in a right Riemann sum, the height is determined by the function's value at the right endpoint of the base. When the function is increasing, the left Riemann sum is an underestimate, and the right Riemann sum is an overestimate. When the function is decreasing, the left Riemann sum is an overestimate, and the right Riemann sum is an underestimate. Part 9. What is a trapezoidal Riemann sum? How does concavity affect their approximations? Trapezoidal Riemann sum is a method used to approximate the area under a curve by dividing the area into a series of trapezoids. If a function is concave up, the trapezoidal sum is an overestimate. If a function is concave down, the trapezoidal sum is an underestimate. Part 10. How do you approximate the area under a curve using left, right, and middle Riemann sums with equal subintervals? For each Riemann sum, you will first have to divide the interval into n equal subintervals. The width of each subinterval, or rectangle, is denoted by delta x, which is b minus a over n. For a left Riemann sum, the height of each rectangle is determined by the function evaluated at the left endpoint of each subinterval. The left Riemann sum is the sum from I equals 0 to n minus 1 of f of x sub I times delta x. For a right Riemann sum, the height of each rectangle is determined by the function evaluated at the right endpoint of each subinterval. The right Riemann sum is the sum from I equals 1 to n of f of x sub I times delta x. For a midpoint Riemann sum, the height of the rectangle is determined by the function evaluated in the middle of the left and right endpoints of each subinterval. The midpoint Riemann sum is the sum from I equals 1 to n of f of x sub I times delta x, where x sub I is the midpoint of the I subinterval as shown here. Part 11. How do you approximate the area under a curve using left, right and middle Riemann sums with unequal subintervals? For each Riemann sum, you will first have to divide the interval into n subintervals. The width of each subinterval, or rectangle, is denoted by delta x, which is b minus a over n. However, for unequal subintervals, each delta x is different depending on the interval that you are considering. The left Riemann sum is the sum from I equals 0 to n minus 1 of f of x sub I minus 1 times delta x sub I. The right Riemann sum is the sum from I equals 1 to n of f of x sub I times delta x sub I. The midpoint Riemann sum is the sum from I equals 1 to n of f of x sub I times delta x sub I, where x sub I is the midpoint of each subinterval calculated as x sub I minus 1 plus x sub I over 2. With unequal subintervals, the widths change, so you can't factor our delta x. You have to treat each term separately, using the actual width of each subinterval. Part 12. How do you approximate the area under the curve using a trapezoidal sum with equal subintervals? Like the other Riemann sums, for a trapezoidal sum, you will first have to divide the interval into n equal subintervals. The width of each subinterval, or rectangle, is denoted by delta x, which is b minus a over n. Instead of a rectangle, each subinterval will form a trapezoid. The height of the trapezoid is delta x, and the two bases of the trapezoid are the function values at the left and right endpoints of the subinterval. The trapezoidal sum is the sum from 1 to n of delta x over 2 times f of x sub I plus 2 times f of x1 plus 2 times f of x2, and so on. Part 13. How do you approximate the area under the curve using a trapezoidal sum with unequal subintervals? When the interval from a to b is divided into unequal subintervals, you can't use a single delta x. Instead, each subinterval has its own separate width. each base of the subinterval is still determined by the left and right endpoints. Instead of one delta x being multiplied by each of the added bases, there are multiple delta x terms depending on which subinterval is being considered. The trapezoidal sum with unequal subintervals is the sum from I equals 1 to n of x sub I minus x sub, I minus 1 times f of x sub, I minus 1 plus f of x sub I. Part 14. What are the two ways you can write the integral from negative a to a for an even function? For an even function, you can write the integral from negative a to a of f of x dx as 2 times the integral from 0 to a of f of x dx. You can also write this integral as 2 separate integrals. That would look like the integral from negative a to 0 of f of x dx plus the integral from 0 to a of f of x dx. Part 15. What does the integral of an odd function from negative a to a equal? This equals 0. Odd functions are symmetric about the origin. In other words, the area under the curve is as much negative as positive, so it cancels out. For an odd function, f of negative x equals negative f of x. If we look at the integral from negative a to a, we can see that this is the same. If you add these functions on one side of the equation, it equals 0. Part 16. What is the limit definition of a definite integral? Firstly, this question is very important because it ensures that the exact area under the curve is found, not just an approximation. It is the foundation for more advanced calculus, as well as the fundamental theorem of calculus. Written out, the limit definition of a definite integral is this. Integral from a to b of f of x dx equals the limit as n approaches infinity times the sum from I equals 1 to n of delta x times f of x sub I. Delta x equals b minus a over n. Part 17. What is the definite integral equal to if the top and bottom bounds are equal? The integral from a to a of f of x equals 0. This is because there is no interval to measure area over. These core ideas, how antiderivatives work, how we use Riemann sums to approximate area, and how the fundamental theorem of calculus connects limits to integrals, are foundational to mastering calculus. Understanding these concepts will help you not only solve problems, but also make sense of the deeper structure of calculus itself. Review these topics carefully and practice applying them to functions, graphs, and equations to build a strong foundation for the rest of the course. Thanks for watching, and don't forget to subscribe for more clear and complete calculus lessons.